Let's talk about a couple of ways we can use tree diagrams to help us calculate probabilities. Now, first off, let's start really simple with the problem we've already done. Let's say you toss a coin, and we're going to add some branches here. So let's start with the first time you do it. So you can have heads or you can have tails. Those are the only two outcomes. But let's say then you toss it a second time. Well, again, you can have heads or tails. Heads or tails. And now you see we have 4 outcomes. Basically, the number of outcomes are the ends of our branches. We could have heads, 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 tails, tails, heads, tails, tails. Well, now let's say we toss it a third time. So heads, tails, heads, tails, heads, tails. So now, why didn't I have enough in there? Try and keep myself organized there. Now you'll see we have 8 outcomes, all the ends of these branches, even though I kind of squished that one. And again, we say, well, how many are there that have 3 heads? Well, 1, 2, there's only the one. This 1 out of 8. But if you said, well, how many of them are there that have 2 heads and a tail? Well, this one has 2 heads and a tail. This one has 2 heads and a tail. This one has 2 heads and a tail. So 3 out of the 8. So if you just said, well, what was the probability we had 2 heads and a tail? It would be 3/8. So this is a really nice way of counting outcomes. Now let's do one that's a little bit different. Let's pretend for a second you have a really limited wardrobe. And let's say you say, well, I can either wear jeans or I can wear, some kind of more comfortable pants. We'll just call them sweatpants for now. Okay? And that's it. Those are your choices. You're either going to wear jeans or you're going to wear sweatpants. Then you say, well, I've got 3 different kinds of t-shirts I can wear. So you'd say, well, all right, 3 different types. Let's just name them like blue, white, and red t-shirts that would go with these outfits. Okay, I suppose I should say, like, here's pants, here's t-shirts. And then you say, well, I got to wear something over it. I might get cold in the Minnesota winter. So you say, well, like a sweatshirt or some kind of, we'll call it top layer. And you say, well, I could wear a sweatshirt or I could wear like a sweater. Or I could just wear like, who knows? Let's say sweatshirt. So sweatshirt or a sweater. Sweatshirt, sweater. I'm really naming these things well. And you say, well, how many different outfits could I pick using only my limited amount of jeans and my 3 colors of t-shirts? So you could say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outfits. But the other nice thing is you could say, well, what if I just, picked a day at random? I didn't even plan my outfit to coincide at all. What's the probability I ended up with jeans and either a white or red t-shirt and a sweatshirt? You could say, well, jeans, white sweatshirt, red sweatshirt. So 2 out of those 12 outcomes. And again, this is just a really nice way to count and organize yourself with getting the number of outcomes and then also being able to quickly count, well, what's the successful outcome? Let's say instead you were like, what are the chances I end up with a sweatshirt and either a blue or red t-shirt, so sweatshirt, blue or red, and I chose a sweater. So you'd say, well, that way. So that's 2 out of the 12 possibilities. So again, it helps us just count, number 1, how many total outcomes, but then also it helps us count what constitutes that numerator, what means a success. Let me show you one other thing we can do with these. Let's say I'm planning my commute home on a Friday, and I can either take, normal like Highway 61 through White Bear, maybe run into some stoplights, things like that, or I could take, kind of snake around a 35E and maybe get lucky and not have to worry about all of those stoplights, but again, I might get caught in traffic. So let's start with this. Here's, I'm starting off, I say, well, I have two choices on a Friday. And I could either take Highway 61 or I could take 35E. And from past experience, I probably take Highway 61, 80% of the time, and 35.2. Okay, so that's the probability on any given Friday that I take Highway 61 is 0.8 and 35E is 0.2. So again, not only did I put the outcome, but I also put a probability. Next, let's just say that the probability that I get caught in some kind of traffic, I'm going to denote it this way. If it takes me more than 12 minutes on 61, or less than or equal to 12 minutes. I'm going to run the same thing here. Greater than 12, less than or equal to 12. That's what I kind of think is success on a Friday afternoon getting through White Bear Lake. Let's say that on a Friday, this happens about 0.4. Like 40% of the time, it takes me longer. Well, of course, then the other 0.6 takes me less. But if I take 35, let's say it's like 0.2, and then, of course, this one is 0.8. Well, now I've changed the probabilities. On the previous examples, we were saying, well, everything was 50-50. Heads and tails was 50-50. I was just randomly picking an outfit. But now we actually can multiply these probabilities and figure out, well, what's the probability that you take 61, Highway 61, and it takes more than 12 minutes. You simply multiply. 0.8 times 0.4 is 0.32. You can do that on your calculator. What if I took Highway 61 and it was less than 12 minutes? I'm going to write the word and there. Well, 0.8 times 0.6 is 0.48. I want you to just pause here for a moment and notice that these two numbers right here would add up to be 0.8. That's because it is the whole 80% of the time I would have taken Highway 61. Okay. Let's do the same thing with 35. If I were to say, well, 35 and more than 12 minutes, so let me write 35 and more than 12 minutes. If I multiply 0.2 and 0.2, I get 0.04. And then, of course, multiplying those other two, let me write this is 35 and less than 12 minutes. That would be 0.16. So again, to get these numbers, I simply multiply. 0.8 times 0.4, 0.8 times 0.6, 0.2 and 0.2, 0.2 and 0.8. And again, notice these two add up to 0.2. Notice that all four add up to 1, because this is everything. Now, if my only question to you was, what's the probability that it took less than or equal to 12 minutes, you would simply go to the 2, less than 12, and you would add those two together and get 0.64. So we can do these with either just counting possibilities, or we can actually change the probabilities on them as well and answer quite a few difficult questions.